Subscribe now and press the bell icon. Never miss an update.
Hello guys, this is Anpichan. Welcome to my mathematics class. Let's study today's topic. Today I've taken this topic, motion under gravity. Motion under gravity, important questions. So I'm today going to tell you the very important questions of motion under gravity. But before doing the question, I would like to show you the key points, right? Before doing any question, I always tell you the key points, and you can say in another sense, okay? Before going into the war, we need to be familiar about the weapons. The same thing I do here. Come on. Everybody today can see these are the key points I've written here. Key points before doing the questions of motion and gravity, we need these key points, right? These you can say these important things as a formula or important key points. Equations of the motion for a body moving under the action of the gravity, right? Gravity for falling body, because when we talk about the motion under gravity, we have two types of the body falling downwards under the influence of the gravity, another one, if we throw the any object vertically upwards, that will be your motion against the gravity, right? Let's see. For falling body, firstly we are talking about the falling body, equation of the motions for falling body, we have three equations. First one, v is equal to u plus gt. V is equal to u plus gt, and as we know, this one is usual, meaning this one is final velocity and this one is initial velocity. G is gravity, acceleration due to gravity. T is a time taken, right? And the second one, we have second one, h is equal to ut plus half gt square. H is your height attained by the particle in time t. U is initial velocity and g is acceleration due to gravity. Okay, t is time. So third equation we have, v square is equal to u square plus 2gh, right? Again, I'm going to tell you the v is your final velocity, u is your initial velocity, right? V is your final velocity of the particle or any object, you can say, and u is your initial velocity, the velocity which is used to project the body. Okay, so same thing here for rising body, the equations will be the same, okay? But here, instead of plus sign, we need to take the negative sign. Here, here why we take the negative sign? Because we throw the any object against the gravity. That's why, we take a negative sign. V is equal to u minus gt, here, plus, because falling body, here rising body, or throwing upwards vertically. H is equal to ut minus half gt square, v square is equal to u square minus 2gh. The same thing, everything is same, only there is negative sign instead of positive sign. Listen to me everybody here, falling down, vertically falling down body, and rising, up means throwing vertically, upwards direction. This will be against your gravity and this will be your towards gravity, right? And this body is falling, right? And I have not used your initial velocity, so here velocity is 0, and but body is falling downwards due to the acceleration of the gravity, right? If we throw upwards direction any body, upward direction any body, then we need initial velocity, right? And we throw against gravity, that time we need to take the negative sign. So these two formula again, I have written here especially. This one is ht is equal to u plus 2t minus 1 over 2 times g, and this formula means height covered, travel, you can say height covered or travel in t at time. So listen to me, not t seconds, but t at time. What is the meaning of t at time or t seconds? Like, so here, if you use this formula, and here you can find out the final velocity, or if you need initial velocity in time 5 seconds, 3 seconds, like this way. And here if you use this formula, you can find out height attended, height right, covered by the your particle or any body in time t second, if 5 seconds, 6 seconds, 7 seconds, then you need to use this formula. When we will use this formula, as t is equal to u plus u is your initial velocity, 2t minus 1 within bracket over to time g. This formula we will use. Here I have written height covered or traveled by a particle in tth time. T time means if we need to find out the height attained by the particle in 7th second. 7th means the during between 6 and 7. 6th second, the during between 5 and 6. That time we need to find out this formula, right? Tth second, ht, right? Height attained, height covered, height traveled in 5th second, then we need to use this formula, right? But if you are falling down, if your body is rising up, then you need to take your negative sign. Obviously you can understand that thing, right? Okay, now I guess you understood this formula also when we use this formula. And the next one formula we have taken, but these all things we have derived from the basic or fundamental equation of the motion of a body moving under the action of the gravity, right? And the next formula we have also derived here. So you can see minus h is equal to ut. This is a ut minus half gt square. When we will use this formula, important thing, this formula. So I made here diagram, right? So diagram, actually, this formula we apply when you throw anybody in upward direction. Suppose this is the point of this one is your this here, this is the point of projection. You are projecting body, all right, it's no problem, we can handle with any one out of 3 equations, right? But but if you throw upward direction but it moves downwards, and then particle is moving in opposite direction finally from the point of projection, because you projected in upward direction but up to here, but now it's going downwards, right? So this means particle, you are going to throw the particle from from certain height, right? From a certain height, right? So here suppose here all right, so this is the height h, and if you throw from here particle, and it goes off, and after some time it comes down, but up to here, then but it goes down. Ultimately this will be your equal to the height of pen, will be your ultimate displacement, right? For this we need to use formula, this one, right? Minus h is equal to ut minus half gt square. Why we use minus h? Because it travel, it goes just opposite of the point of projection, right? Because we projected in upward direction, but finally displaced, it covered the distance just below the point of projection. So here suppose here look at here, everybody, this one here, and here so this is the height, certain height, here projector. So body is u is the bell, body is here, at point A, body is here. Body is projected from the point A. Body is projected from A. The body is at certain height, at height h, Body is already at height h, means now we are going to project from here. Initially, u is the initial velocity of the body. Now you are going to project it, and it goes in upward direction, and in upward direction, and after some time it comes down, and after attaining the maximum height, then it comes down, automatically, and but your body doesn't stay here, and the body moves downward direction, and suppose this is the ground, you are here at a certain height, and body drops here, body ultimately body drops here, and finally your body displaced only this, this much only. So you are here, you project in an upward direction, but now finally body is here, so body is here, right? Body is here, and your total distance covered is h only, right? So for this this type of scenario, we use this formula. Okay, minus h, okay, minus h is equal to ut minus half gt square. You can apply just, okay, h is equal to ut minus half gt square, because, okay, body is just below the point of projection, right? Means opposite direction. Thus we need to take the negative side. Okay, so I guess you have no problem about the key points and the important things, right? So okay, so now let's start the important question. This is the first important question, and one by one I will tell you, right, important questions. Okay, so now I'm going to, okay, start the first question. So let's move, okay, into the first question. How to do? So I guess now you are all clear about the key points. I meant to, okay, important things, right? If you know, okay, these are key points, okay, then definitely you are gonna solve each and every question of this topic, means motion under the gravity. At least, okay, you can do some of them definitely. There is a no problem. There is a no doubt. Okay, if you know all these, okay, equations, right? These, okay, these equations, and these all things, these all important things. Okay, so let's move into the questions. Okay, now I need space. As you know, I don't have a so big one board, so I need, okay, space. So that's why I'm going to expunge all these things. Okay. Um, uh, Now, okay, let's start. Solution. First one, we need to write on this board. Okay, solution. Three particles. Let's read the questions. And one more thing, listen to me, everybody, in mathematics or in physics, okay? So, any type of numerical you are going to solve. But firstly, okay, you should read the question very carefully. And if you don't understand once, okay, then read, okay, twice, thrice, okay? And until you are clear, right? Once you clear, then you can do very easily, right? Then no problem, okay? Then nobody can stop you to crack down this question, okay? So let's study, okay? Three particles are simultaneously projected vertically upwards from the heights h1, h2, h3 above the ground with velocities u1, u2, u3 respectively. Listen to me, everybody, okay? I'm going to show in diagram. Uh, let's suppose, okay, here, this is the ground, okay. Three particles are simultaneously projected vertically upwards from heights. Already, okay, particles are at certain height, okay, here. According to this one, this particle, okay, is here, okay. And initial velocity, the projection velocity u1, right? Means, okay, velocity of the projection is your u1, initial velocity. And then, okay, another one, okay. So yeah, A, let's suppose, okay, B, okay, or towers, and any, okay, anything you can say, h2 height, and body is going to be projected, particle is going to be projected from here, and its initial velocity is u2, and third one, okay, we don't know the heights, okay, but they are different, okay, that's why I'm making, okay, like this way, uh, h3 height, okay, we are going to project the particle, okay, from here, so u3, and its, okay, initial velocity is u3, okay. So at certain height, okay, particles are at certain height, right? So okay, three particles are simultaneously projected, means, okay, at the same time we are going to project vertically upwards, okay, from the heights above the ground, velocities, okay, with velocities, initial velocities u1, u2, u3 respectively, and all of them reach the ground at the same instant, okay, means same time, okay, they strike the ground, okay. See, so it moves, okay, we don't know that finally, okay, it comes here, right? And the particle, okay, and it goes, okay, up, and after some time, okay, okay, your particle strikes here, and it goes also upward direction, and finally, okay, and your particle, okay, strike here, but okay, the all these particle, okay, strike the same time, okay. This means, okay, they take the same time, okay, to come back on the ground, okay, you can say. All right, so here last one key point, okay, last one formula we will use, right? Because we are throwing in upward direction after, means, okay, from a certain height, okay, from a certain height, and our particle goes in opposite direction from the point of projection, right? So okay, so here let t be the time, we can suppose let okay t be the time taken by the particle. So only this, okay, in shortcut I have written let t be the time taken by the particles, right? Then okay, then they take the same time, okay. Then for the first particle, using formula h1 given I minus, because in opposite direction, okay, right? So here from here projected, but it moves, okay, downward, just opposite of h1 is equal to, against gravity we are going to u1 t minus half gt square, first case. For second particle, minus h2 is equal to u2 t minus half gt square, and for third particle, so for third particle minus h3 is equal to negative h3 u3 t minus half times gt square. Okay, so very simple. We need to prove this one. This plus this means, okay, u1 times of this plus u2 times of this plus u3 times of this is equal to 0. All right. So I guess diagram is clear and its space. Okay. Now, okay, well, let's see, okay, how to do. Okay, now I'm going to subtracting because we need, okay, h2 and subtracting second from first, we get, so see, you can subtract, okay, second from first, minus h1 is equal to u1t minus half gt square, write down, okay, h2 second here, u2t minus half gt square, okay. Subtracting, you are going to subtract second from first, so let's change the sign, minus and plus, okay, here h2 minus h1 is equal to u1 minus u2 times t, and they're same, and so that's why they will cancel out, right? They will be cancelled out. Okay, let it be same, let it be in this position. This one is you can say because 1 2 3 4 number, this relation is 4. Subtracting okay, now that, okay, h2 minus h1 we got value. Now we have to get, okay, h3 minus h1 or h1 minus h2, right? Okay, you can h2 minus h1, h3 minus h1. Okay, I guess let me this one is h2 minus h3 here, so some mistake. Alright, h2 minus h1 plus u2 h3 minus h1, h1 minus h2, h2 minus h3, h3 minus h1. Alright, now, okay, sequence is now right. Here h2 minus h1, actually I need, okay, h1, okay, so let's make, okay, 1 minute, okay, I can correct it from here. We need, okay, let's change the sign, okay, and you will get, okay, here h1 minus h2, right? h1, actually we need, okay, h1 minus h2. If you change the sign, okay, you will get, okay, here u2 minus u1 times t. Okay, so no problem. All right. u2 minus u1 times t. This one is your phone number. And similarly, I guess we can get, okay, same, okay. Similarly, you need to subtract, okay, right? You need to subtract to get, okay, like h1 minus h2, as I got, okay, here subtracting, okay, and now just I got, okay, h1 minus h2, and to get, okay, h2 minus h3, h2 minus h3, you can subtract, okay, second from third, you can subtract second from third, okay, and then, okay, to get, okay, h3 minus h1, okay, you can subtract, okay, third from first, okay, third from first to get this one, okay, h3 minus h1's value, right? I'm writing, okay, directly, so I guess, okay, we'll get, okay, h1 minus h2, we got this one, and then similarly we can get, okay, h2 minus h3 is equal to, I guess, u3 minus u2 times t, and h3 minus h1 is equal to u1 minus u3. I think, okay, right? According to this I have written, so we'll check, okay, right? And this one is a 5 number, and this relation will be your 6 number, right? Now we will put, okay, the value of this, and this in left hand side. Now you can take, okay, left hand side. Now left hand side, we have left hand side, okay, u1 h2 minus h3 plus u2 h3 minus h1 plus u3 h1 minus h2, right? So left hand side, I've taken left hand side. So left hand side from here. Now you need to put the value, okay. So you from 4, 5, 6 you will keep, okay. h1, okay, h3 minus h1, u1 bracket h3, h2 minus h3 means u3 minus u2 times t plus u2 times, what's the value of h3 minus h1? h3 minus h1 from here, u1 minus u3 times t, and plus u3 times, what is the value of h1 minus h2? Where is h1 minus? u2 minus u1 times t, okay, is equal to here t common, inside the bracket u1 u3 minus u1 u2 plus u2 u1 minus u2 u3 and plus u3 u2 minus u3 u1 is equal to u1 u3 minus u3 u1, same thing, cancel, on negative u1 minus u1 u2 here, positive, okay, cancel, and okay, cancel, right? So finally you got, okay, t times 0 is equal to 0 is equal to right hand side. I guess now you have no problem. You understood this question, right? Now I'll write down the second question. I'll take, okay, second question. So I don't think now you have problem, right? So if you have problem, you can ask me. Don't hesitate. Okay.